Hi class. So today we'll be introducing the Module 7 lesson of 7.1b. It is on finding the area of irregular shapes. And what we're doing is basically calculating shapes that really are a combination of multiple shapes. You could see how something like letter B is really just two rectangles in one. You can see how letter C is kind of like a rectangle with two semicircles. And all we would have to do is calculate the area of this rectangle plus the area of this circle. Now, since this has been a little bit challenging for students where we don't have the printout, I'm actually going to skip this entire page. I will have it available for those of us that want to try it, but I am going to go to number 2 of the lesson. And unfortunately, this is my second time making the video because the first time the audio was not recorded. So I really hope you can hear me right now. And I just went over this lesson, so I'm going to recap it with the notes already filled out. Okay, so something like number 2, you can see how this is a parallelogram with another parallelogram. So what you're going to have to do is you want to cut the parallelogram in half and kind of find the area of this shape and then find the area of the shape below. Now, the thing we have to remember is the area of a parallelogram is still going to be the base, which here is 30, times the height of the parallelogram itself. Notice how we're not using the numbers that we call these the slant heights. Right? We don't care about the slant heights because we want to know how tall the actual parallelogram is. So the area is still base times height, and I did 30 times 40, which gives me 1200. It's really just two of them, so the total area is simply 2400 centimeters squared. Okay. The next question, number 3, is going to be somewhat complicated, so just try to pay attention and see what I did here. Okay, so we know that this arrow is pointing, that looks like it's pointing down, really is a combination of a rectangle and a triangle. To me, I think the rectangle, calculating the area of the rectangle is decently easy because the dimensions are given right away. So you know that it's base times height, which is 23.7 times 32.4. So as you can see in my work, I did 23.7 times 32.4, and I got 767.88 meters squared. Okay, so far so good. The challenging portion of this question is to calculate the area of this triangle. And I just want to be perfectly clear here, class. You have to take the entire base, which is this portion, and you have to multiply by the height of the triangle. Okay, you can see in this picture that I drew, you take the base, you multiply by the height of the triangle. Not only do you have to do that, you also have to divide it by 2 because it is a triangle. So in order to calculate the base, what I did is I calculated 9 plus 3 plus 23.7 right here, plus another 9.3. So I use my calculator, and I end up getting, 9.3 plus 9.3 plus 23.7, and that gave me a base of 42.3, which I wrote right here. Now, to calculate the height of the triangle, you also have to, it's not given, right? We don't know what this is. But the one clue that we have is the fact that the entire height of the object is 49.8. And we know that this height right here of the rectangle was 32.4. So all I really have to do now is just take 49.8 and subtract 32.4. And that gives me a height of 17.4. Once I know the base and I know the height, all I have to do is multiply these two, 42.3 times 17.4, divided by 2 because it is a triangle, and then get my area of the triangle. And then finally, once you have the area of the rectangle plus the area of the triangle, you then combine them, add them up. My total area was 1,135.89 meters squared. This is a really, really good question. And I definitely want to take your time on this and rewatch this video if you're curious about how I got these numbers. Obviously, the notes will be posted. Okay, so let's go to the third question of the lesson, and it deals with this track and field. So I'm going to read it very quickly. It says a rectangular field with two semicircles at each of the shorter ends of the field measures 100 yards long and 40 yards wide. Okay, so this is kind of accurate. Not exactly the most accurate of a regular track and field that you may have seen in colleges or high schools even, but it is surrounded by a track that is 5 yards wide. Find the area of the field, which includes the two semicircles on each of the shorter ends of the triangle. Then they also want you to find the area of the track. Okay, so this is kind of challenging. The area of the field really consists of a rectangle and two semicircles, right? But how would you calculate the area of the track? Remember, the track is the portion where the athletes run around the track. How would you calculate that portion? So it's similar to the donut question or the circle within a circle question that we have done in the past in Module 6. In order to calculate the area of the field, I think that's straightforward. You calculate the rectangle and you add another circle. But to calculate the area of the track, you would first have to calculate the total area of this entire shape, everything included, and then you subtract the area of the field to get this border area, right? So I'm going to write entire area on the left. And you can see why I wrote entire area on the left, because I then want to subtract the entire area minus the area of the field to then get area of track, the track. Okay, so let's first talk about the area of the field. The width of the rectangle here is 100 yards. The height is going to be 40. So the area of the field is 40 times 100, which is 4,000. We then know that we have a circle. So it's really just two semicircles. So that's a complete full circle. And the only thing we need to know about the circle is the radius. Since the radius is 20, because it's 40 divided by 2, we then took 20 and did pi times 20 times 20, and we got 3.14 times pretty much 400 to get 1256. Okay, so then now you can see how I added 4,000 with 1256, because that's the entire area of the field, to get 5,256. Okay, please pause the video here if that was overwhelming for you or that was too much, because I think you definitely want to review what we just did in this step. Okay. Okay, so the next thing we have to do is we're going to have to calculate the entire area. So that's like this purple region, everything in it. So now we notice that the height is, or the base is still 100. So I'm going to write rectangle here. I'm just going to write rect. And we write 100. Now the height of the rectangle is no longer 40. They added 5 this way and 5 that way. So that means that the entire height of this rectangle is now 40 plus 5 plus 5, which is actually 50. So it's 50, and you'd still have a width of 100. So it's 100. That gives me 5,000. Okay, the circle, well, when we change this height to make it 50, doesn't that also change the radius of the circle? The radius is no longer 20. It went from... it now has a diameter of 50. So if the diameter is equal to 50, that means the radius is equal to, you said it, 25. So now let's find the area of the circle, right? There's two semicircles. So we know it's pi, which is 3.14, times 25, times another 25. That's pi r squared. So really, go ahead and use your calculator here, and you get 25 times 25, 625, times 3.14, and that gives me 1962.5. This is in yards squared. Okay, class, we worked really, really hard to get these two values. Remember, this is just a rectangle with a circle. So now you then have to subtract these two numbers to find the area of the track, right? The area of the track is going to be 1962.5, the entire area, minus the inner field. And I'm noticing an issue, a very, very important issue. What did I do? I forgot to add the rectangle and the circle together, right? There's no way that the entire area is 1962 if the area of the field is 5256. So what I forgot to do is I obviously forgot to add the area of the rectangle with the area of the circle. So the entire area is now 5,000 plus 1962, which is 6962.5. Then I'm going to minus 5256, and that's going to give me a grand total of 6962.5 minus 5256 is going to give me a grand total of 1706.5 yards squared. So the area of the track, so you say the area of the track is 17.06 yards squared, and the area of the field is 5256 yards squared. Okay, they asked us two separate questions, so it's only proper if we answer both of them. Okay, this is a lot of work. So definitely want to review this video again. This was the 7.1b lesson. You can see how we didn't do all the problems, but hopefully these three example problems of finding irregular shapes make sense to you. You do want to label everything. You want to write down all your steps, right? Being a good student is when you organize all your work and you can just understand exactly what's going on. I tried my best to provide a lot of detail, but obviously I know you may have questions, so go ahead and leave me a question on the comment section if you are still confused about something. Okay, see you next time.